Hey guys, welcome back. Now let's have a look over a new ADC, that's analog to digital converter, and it is MCP3425. And to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this sensor. As you can notice on my screen, it's MCP3425, and let's see what we got for this ADC. And as we see, it's a 16-bit one channel ADC, and these are some more features of this ADC, as you can notice on my screen. And this here is the section from where you can buy or add to cart. For the interfacing part, I will be taking care of this ADC MCP3425 with a BeagleBone black, and the language platform I will be using is C code language. And to get your C code, here it comes. Go to the source tab, and after that, clicking on the C code sample, you can download the code as a zip file. And you can also get your code from github.com, and the concerned repository there is Control Everything Community. Now let's have a look over the hardware connections we need to get up together, and let's see how we do that. Well, for the hardware connection setup, the first thing we require is the BeagleBone black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently inserted here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Next, we require our analog to digital converter, that is MCP3425, and this here is a connecting cable. Now make the connection among the ADC and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the analog to digital converter, and similarly to the ground of I2C Shield. Now we are done with all the connections for this hardware. Now let's have a look over the code. Well, now for the interfacing section, we have to log into github.com, and here we have to search on for the repository, that is Control Everything Community. After getting that, this is our ADC, that is MCP3425, and here this is the C code, as you notice. Now for the instructions part, let's roll upon, and as you notice, we have to set up our BeagleBone black, as you notice, on to the sensor, onto the ADC specifically. And this link, BeagleBone.org, is the exact link from where you have to do the setup. As you notice, this is the link, this is the site from where you can have your setup procedure done, along with all the instructions, and the procedures need to be fulfilled carefully. After getting this done, you have to download the code onto the BeagleBone black, and this is the command for the compilation step, and this is for the running of the C code. Please note it down carefully, and then get back to C code. Now as you notice, it's a .c extension file, and also in the code, first of all, we have included some of the header files, as you notice, and in the void main function, we have created a variable here, and then we have to check whether the bus is open or closed, and then we have to check for the I2C device and the address of the ADC, that is 0x68. Then in the writing section part, as we know, we are going to select a configuration command, that is 0x110, and continuous conversion mode with 12-bit resolution, and it comprises of 0x10, and the writing command is here. Then we have a delay or sleep of 1 second, and then we are going into a reading section where we are going to read, as you notice, 2 bytes of the data from the register 0x00, as you notice, and here is the command for that. And after that, we have the conversion of the data, which we have seen according to the guidelines provided in the datasheet for ADC MCP3425. At the very end of our code, we have the output data to be displayed onto the screen, which is the digital value of analog input. So this is how the code looks like. Now let's see how it works. Now Coming to the working part, which is really important and it's very interesting, and in this part we need to copy the entire code as you see on my screen. And after copying, we have to open up the terminal for the BeagleBone Black we have connected, and here we have to create a new file as you can see, and the extension will be .c, and here we have to paste the entire code, and after getting the code we have to save it, and here we go. And this command is to compile, as we know. .c will be the extension, and here the full command is here onto your screen. And let's see what we got here. The code compiled successfully. Now to build the code we have this command, and let's see what we got here. We have the digital value of analog input and it is 0. When I again run the command we have the 0 value, which means either the terminals are grounded or nothing has connected. But instead, when I try to connect a AA battery of 1.5 standard voltage and I run the command, we have the digital value of analog input, which will be 1048, and again when I run it will be still 1048, which means it's constant. The battery is connected across the ends of the terminal for the sensor, and the sensor is responding in a well condition. Now let's have a look over the applications and some of the benefits regarding this sensor, that is the analog and digital converter. The MCP3425 is a single channel, low noise, high accuracy analog to digital converter with differential inputs and up to 16-bit of resolution. The onboard precision 2.048 volt reference voltage enables an input range of plus minus 2.048 voltage differential. The device uses a 2-wire I2C compatible serial interface and operates from a single 2.7 volt to 5.5 volt power supply. The MCP3425 device can be used for various high accuracy analog to digital data conversion applications like portable instrumentation, base scales and fuel gates, temperature sensing with RTD, thermistor and thermocouple, and bridge sensing for pressure, strain and force. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site you can download the code as zip file. Also you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.